everyone, today we are going to be reviewing inequalities in two variable equations. And the way it's going to work today is I'm going to have you guys practice a page at a time, and then I'm going to come back and go through all the answers. For this first page, that's the inequalities review. I put screenshots up here of everything that I think will be really helpful for you. So feel free to reference these screenshots. Please complete this entire page and then come back when you're ready to see me go over it. All right, hopefully you're ready to see me go over it. So problem 1, you should already have this all done. It says Jonah reads less than 6 pages per minute, which graph represents this inequality. So less than does not have that or equal to component. It's this symbol, and I know that that symbol has an open circle. So right away I can eliminate C and D as choices. I know it has to have an open circle, and then I have to decide which arrow I want. Well, I can eliminate A because that has numbers that are bigger than 6. So B has the numbers that are less than 6. Obviously, he can't read a negative number of pages per minute, but this would still be the representation of the statement. So B is the correct answer there. Then write the inequality for the number line you chose. So to find the variable, pages seems like the quantity, so let X be pages. And then for the inequality, I know it's going to be X and 6, and then less than is that symbol. I already determined that earlier. So check your work, fix yours if you had different answers. Now you should already have problem 3 done as well. If you don't, or you feel like maybe you did something wrong, feel free to fix it before I go over problem 3. So the situation for 3A, your frozen yogurt from Red Mango will cost at least $4.75. And that money sign is my quantity, the at least is my relationship. So define the variable. Let X be money. Inequality, at least. I'm going to reference my chart, see if it's on there. Oh, it's the very first one. At least is greater than or equal to. So X and 475, and then I want greater than or equal to. So the frozen yogurt might cost $4.75, or it could cost more than that. So here's my number line. 0 and 475. Since it's or equal to, it's going to be a closed circle. And then I want numbers that are more than 475. So that would be the correct inequality. Same deal for B. So the relationship is at most. That's R. And then Tootsie Rolls is going to be our quantity. So let X be Tootsie Rolls. At most, let's see. Well, I know I have X and 3. Maybe I'll get those down. At most. Oh, it's the very next one. So it's less than or equal to. So she can have exactly 3 Tootsie Rolls, or she can have less than 3 at once. So I have 0 and 3. Since it could be 3, that's a closed circle, that equal sign. And then I want to point towards the numbers that are less than 3. Okay. Great. So now we're on to the variable relationships review. So this is the stuff that's going to be helpful here. This is where we are going to have our y equals equations, because there's going to be 2 missing elements, 2 quantities, 2 things we don't know. And remember, if it's one relationship word, it'll be one step, like in the pink box. And if there are 2 relationship words, it'll be 2 step, like in the yellow box. I also have the information about independent and dependent variables. Independent variable is usually time, and it corresponds to X always. Dependent variable is often money, and it corresponds to Y always. Go ahead and try this entire page and come back when you're ready to go over it. Hopefully you are ready to go over it. So it says, Aaron is playing a new app on his iPad. He gets 2 coins every day he plays. Identify the independent and dependent variables. Well, what are our quantities? Coins and days. So one of them is going to be independent. One of them is going to be dependent. Time is almost always independent, and I think this is a case where it follows the rule. So the independent variable is going to be time, and the dependent variable is going to be coins. X always has to go with independent variable, so it's going to be time. Y has to go with dependent variable, so that's going to be coins. What is the equation that represents the situation? Well, let's find what our relationship is. So these are our quantities. The relationship, I think, is going to be every, which to me is the same thing as each. So I know I'm going to have a y equals in the equation. It has to start with y equals. 2 coins each day he plays is going to be 2x. Each is usually a multiplication relationship. So if he has 26 coins, how many days has he played? So let's see. Coins goes with y. So that means I'm going to take my equation, y equals 2x, and I'm going to get rid of y and put 26 in that spot because 26 goes with coins. Coins goes with y. To solve this equation, I have to divide both sides by 2, and I get x equals 13. The unit for x is time, which is really days. I guess I could have said days to begin with. That probably would have been a better choice. So, and if that's what you were thinking, you were totally right. You could say days here instead of time. Either one would really work. I wouldn't take off for either one. Days is probably a better choice, though. All right, and then next one. He's played for 16 days. How many coins will he have? So days goes with x. So here's my equation, y equals 2x. And I need to replace the x with 16. But I can't just say 216. It's 2 times 16. That's what 2x means. So that means there's no algebra. It's almost like just doing a check. 2 times 16 is 32. So y equals 32, and the unit for y on this page is coins, 32 coins. Okay. Please try this page all the way through. Pause the video, come back when you're ready for me to show the answers. All right, so here we go. For this, what you have to remember is that here's the x-axis. Even though they label it t, it's really the x-axis. Here's the y-axis. Whatever's on x has to be the independent variable. So the one on that pink axis is time or hours. You could say either one. The one on the y-axis has to be the dependent variable, and that one is, you could say water or you could say gallons. It doesn't matter. So instead of x, I'm going to write independent variable. Instead of y, I'm going to say dependent variable. That's the only way to figure this out. And then down below, we can just copy over either time or hours, your choice. Either water or gallons, your choice. And that's all there is to that one. Now there's 2 review questions. If you haven't done those yet, make sure you pause the video and give them a shot. So if I'm simplifying this expression and there's parentheses here, the first thing I need to do is distribute. If you remember when we learned these types of problems, step 1 was always to distribute. And then step 2 was to combine like terms. It's been a while since we did this. So I'm going to copy down my negative 5x because that has nothing to do with the parentheses or what's being distributed. And I have to multiply 7 times 2x. That's going to be 14x. Then I have to multiply 7 times negative 4y. 7 times negative 4 is negative 28y. And then I have to copy down the negative 10y because that is outside the parentheses too. Now I need to do like terms. So negative 5x and positive 14x go together. Negative 28y and negative 10y go together. Negative 5 and 14 are different signs, so I need to subtract. That gets me 9. The bigger one's positive, so I'm going to keep it positive 9x. Negative 28 and negative 10 are same sign, so I need to add. 28 plus 10 is 38. And then when you add two negatives, you keep the same sign, so negative 38y. This would be my final answer. Lastly, write as an expression. Half the number of kids plus 5. So I can kind of break this into two components around the word plus. I know it's going to end with plus 5. Now I need half the number of kids. I could represent this as x over 2. I could have also used 1/2 x. So then it would just be 1/2 x plus 5. Either one of those is okay. And that